This is an introduction to using fraction bars for fractions. Today we're just going to talk about equivalence. Just a quick introduction to the board. Down here you can choose which kind of piece you want. We've got halves. The nice thing about this is that you get pieces that you don't get in some of your hands-on manipulatives. I've never seen any with ninths or sevenths or 11ths, and so you can illustrate some different ones that perhaps I wouldn't see otherwise. You can shade and unshade, you can split or put back together. Of course, the others are pretty much the same. So let's just start out with a simple one. Let's go with halves. So I will bring out a piece. The very first thing you can illustrate with this is when you cut something into halves, how many pieces do you get? This may seem like a really simple concept to you, but I've had many, many children up in junior high who could not answer that question, who didn't have that really basic concept. So here you've got, when you pull out halves, you see every single time that you get 2 pieces. If you pull out thirds, every time you get 3 pieces, etc. All right, let's shade a half of it. Now, we can compare it. Let's pull out the thirds. Oops. And put it right underneath of it. Is there any number of thirds that I could shade that would be exactly identical to 1/2? No. If I shade 1 piece, it's not big enough. If I shade 2 pieces, it's too big. So let's move the thirds over here. So there's no way that 1/2 halves and thirds can be equal. Let's keep going. Just pull out our fourths, put it under there. Great. Now we can certainly see that halves and fourths we can shade to be alike. Whoops, and if I do it and keep it there, it will help. All right, that one shade. Okay. So we can see that 1/2 is equal to 2/4. Okay. It's really good for the kids to be able to explore this because then they can really see and they can start to develop their own ideas as to how you would know whether it was equivalent to 1/2. All right, if this is fifths, I am having trouble making them stay, as you can see. All right, let's try again. If I shade, if I shade 1 piece is not big enough, 2 pieces isn't big enough, 3 pieces is too big. Won't work. Let's move that one out of the way. So thirds and fifths don't work, but halves and fourths do. Let's bring out sixths. And we can color 3 pieces and see that they're the same. Okay. We can keep going. At this point, I might ask the students, what do you think would be the next one that it would bring out? Would sevenths work? Some of them might not know. If you're not sure, bring it out. It won't work, move it over there. But let's say they said that eighths would work. So let's bring out eighths. Let's shade it. Okay. So now we can start looking at what's the same, what are equivalents. We've got 1/2, 2/4, 3/6, 4/8. Okay. And we can start talking about how would you know what kind of piece you could choose. Well, all the bottom numbers are even. So anything with an even bottom number would be equivalent to 1/2. So you can start working with the concepts. But just letting them explore and actually pull out all the pieces and see whether they can shade or not, or if they have hands-on manipulatives, lay out the pieces and see whether they are equivalent or not, is a great way to start building understanding in the students. Another really neat thing that you can do with the fraction bars, let me erase, maybe, there we go. And everything except for my 1/2 for a minute. I did this by accident when I was doing something else, but you can actually split it. So you can see we've got 1/2 colored in. If I tap it, it will split each half into 2 pieces. So now I have 4 pieces in all, and 2 of them are colored, which was just the same as having 2 pieces with 1 of them colored. So you can keep splitting them. I can split it into 4ths. If I tap it again, it will split each half into 3 pieces, so I've got 6. If I tap it again, I can have 8ths, and so on. So here's just another way of showing the same concepts. Okay? If I want to go backwards, if I want to start with a bigger fraction and make it into a simpler fraction, I have to actually start out this way. If I want to do a problem of, let's do something like, let's do 8/12 equals what? What would be a simpler fraction for 8/12? Okay. You would have to kind of, as a teacher, cheat and know what the answer is. And hopefully you do. You would know that it's thirds. So I would bring out my thirds. Oops, somehow I got a hole. Let's see. You might be able to do it with a hole. I'm going to try that. I haven't tried this yet, so this is a new experiment here. I've got to get it to 12ths, but I can't color that many. Yeah, I could do it, but when I shade the whole thing. That won't work. Okay. So let's bring out our thirds, which is what I started doing in the first place. So you as a teacher have to have this set up ahead of time. Go ahead and divide it until you have 12ths. Okay? So have them look, we can count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Put it up like this. I've got 12ths. I want to shade in 8 of them. Okay? So I now have 8/12 shaded. Okay? What is 8/12 equivalent to? Now I can start ungrouping. So if I tap it once, 8/12 is the same as, now I have 6 pieces colored out of 9. If I tap it again, I have 4 pieces colored out of 6. And if I tap it again, I have my simplest form, 2/3, which is when if I tap it again, nothing will happen. That is its simplest form. So reduced to its simplest form, 8/12 equals 2/3. Okay? So there's just an introduction to fraction bars and how to use them to show equivalent fractions, starting with a big fraction or a simple fraction, going to more complicated ones, starting with a complex fraction and going to those that are more simple.